Hello everyone! Today we're going to tackle a topic that sometimes seems a bit intimidating, but I promise once you see it broken down, it's not so scary. We're talking about polynomials. So what are they? Think of them as mathematical sentences or expressions. They are built from a few simple ingredients: variables, coefficients, and exponents. A polynomial is just a combination of these things, all added or subtracted together. It's kind of like a recipe with different parts. You've probably already seen some simple polynomials without even realizing it. For example, 3x plus 2, or 5x squared minus 7x plus 1. The key rule: exponents must be whole numbers. 0, 1, 2, 3. We classify them by degree, the highest exponent. 3x plus 2 is degree 1. 5x squared minus 7x plus 1 is degree 2. Different parts, terms, make up a polynomial. Identify terms, coefficients, variables, and degree, and you're ready for more. Now that we have a good feel for what polynomials are, let's talk about what it means to divide them. This might sound complicated, but the core idea is exactly the same as the division you learned in elementary school. Like figuring how many times 5 goes into 21, with a remainder. Polynomial division works in a very similar way. We're asking how many times one polynomial, the divisor, fits into another, the dividend. Imagine a long plank whose length is a polynomial, and small blocks that represent a smaller polynomial. The big plank might be x squared plus 5x plus 6, and each small block might be x plus 2. Polynomial division finds how many blocks you can cut, the quotient, and any leftover scrap is the remainder. Sometimes division is perfect with no remainder. That reveals factors. The method is called polynomial long division, and it looks much like numeric long division. Next, we'll break the process into clear, easy steps. Alright, let's get into the mechanics of polynomial long division. The best way to learn this is by walking through the steps. We'll outline them first, then apply them to a real example. The process can be summarized with a simple 4-step cycle you repeat over and over. Divide, multiply, subtract, bring down. Before you begin, make sure both polynomials are in standard form. Terms ordered by exponents from highest to lowest. If any powers are missing, add them with 0 coefficients so everything lines up. This helps keep everything lined up perfectly. Step 1. Divide. Look at the very first term of the dividend and the first term of the divisor. Ask, what multiplies the divisor's first term to get the dividend's first term? For instance, dividing x squared plus 5x plus 6 by x plus 2, to get x squared from x, you multiply by x. Step 2. Multiply. Take that quotient term, x, and multiply it by the entire divisor. X times x plus 2 equals x squared plus 2x. Write that under the dividend, aligned by degree. Steps 3 and 4. Subtract and bring down. Subtract the expression you wrote from the dividend. Be careful with signs. Then bring down the next term from the dividend. In our example, that gives 3x plus 6. Repeat the cycle until you're done. Theory is great, but math is best learned by doing. Let's take x squared plus 5x plus 6 divided by x plus 2 and solve it together. First, set up the division, dividend inside the bracket, divisor on the left. Make sure terms are in descending powers. Look at x squared dividend and x divisor. What times x gives x squared? Answer, x. Write x in the quotient. Multiply, x times x plus 2 gives x squared plus 2x. Write that under the dividend and align like terms. Subtract x squared minus x squared is 0. 5x minus 2x is 3x. Watch the signs. Bring down the next term, plus 6, forming the new polynomial 3x plus 6. Now repeat. What times x gives 3x? Answer, 3. Write 3 in the quotient. Multiply 3 by the divisor. 3 times x plus 2 equals 3x plus 6. Place it under and subtract. Subtracting leaves 0 remainder. Perfect. The quotient is x plus 3. Because remainder is 0, x plus 2 is a factor of the dividend. Division confirmed the factor. Let's pivot and learn how to break polynomials apart directly. Factoring. Now let's switch gears and talk about factoring polynomials. If division is fitting small blocks into a big one, factoring is starting with the big block and figuring out what small blocks made it. Factoring is simply the reverse of multiplying polynomials. For example, x plus 2 times x plus 3 gives x squared plus 5x plus 6. So factoring x squared plus 5x plus 6 gets us back to x plus 2, x plus 3. Why is this useful? Because factoring helps solve polynomial equations quickly. If x plus 2, x plus 3 equals sign 0, then x plus 2 equals 0 or x plus 3 equals 0, giving solutions easily. So the solutions are x equals -2 and x equals -3. There are many factoring techniques. You often pick one based on the polynomial type. Always check for a greatest common factor first. For example, 4x squared plus 8x factors as 4x times x plus 2. Finding factors is like fitting tiles together. The smaller polynomials multiply to recreate the original. Remember, if dividing by x plus 2 gives quotient x plus 3 and remainder 0, then x plus 2 is a factor. Division and factoring are two sides of the same coin. Both reveal structure. Okay, let's build a small toolbox of techniques for factoring trinomials of the form x squared plus bx plus c. We'll focus on simpler trinomials where a equal sign 1. You're looking for two numbers that multiply to c and add to be, a little number puzzle. Take x squared plus 5x plus 6. Here b is 5 and c is 6. List factor pairs of 6, 1 and 6, 2 and 3, and consider negative pairs if needed. 2 and 3 add to 5, bingo. So x squared plus 5x plus 6 factors as x plus 2, x plus 3. If signs are negative, process is same. Example, x squared minus 7x plus 12. Look for numbers that multiply to 12 and add to -7. -3 and -4 multiply to +12 and add to -7. So factors are x3, x4. This sum product pattern is quick and handy. Practice listing pairs to get fast. Remember to check for a GCF first. It simplifies the job. With these tools, you're ready to factor common trinomials. Let's solidify this by factoring x squared plus 2x minus 15 from start to finish. Identify b equals 2, c equals -15. We want two numbers that multiply to -15 and add to +2. List factor pairs, 1 and -15, -1 and 15, 3 and -5, -3 and 5. Check sums. -3 plus 5 equals 2. That's our pair. Write the factors as x3, x plus 5. Multiply them to verify. FOIL gives x squared plus 2x minus 15. Match confirmed. There you go. Factored and verified. Practice a few of these and you'll speed up quickly. One of the best things about algebra is you can usually check your own work. For polynomial division, quotient times, divisor plus remainder equals dividend. For x squared plus 5x plus 6, x plus 2, quotient is x plus 3, and remainder is 0. Multiply the factors. FOIL, first, outer, inner, last. Combine like terms to return x squared plus 5x plus 6. Factoring check is just reverse multiplication. Multiply factors and see if you get the original polynomial. Make verifying a habit. It saves small errors and builds confidence. Tip: always line up terms, watch signs, factor out GCF first, and verify with multiplication. We've explored polynomial division and factoring, step-by-step long division, and puzzle-like factoring of trinomials. These skills unlock real-world problems, from projectile paths to engineering models and economic trends. They help simplify complex expressions and find roots. Practice these techniques and you'll get faster and more confident. Keep practicing, and you'll see how powerful they can be. Thanks for watching.